Okay, so for the percentages problem, the square problem with the changing percentages, I recommend drawing a picture. So we're going to draw a square. Okay, in the original we had diagonals that crossed and broke the square up into equal parts. 25, 25, 25, and 25, right? And then the new square is the result of taking the diagonal from this corner and shifting it down halfway so that now it bisects that side length. Okay, so now we have a new square that we can draw with new portions that has this diagonal did not change, but this diagonal is now going to start in the midpoint, go down. Obviously, lines should be straight. I'm not very good at drawing, but the question is, what are the new percentages, right? What are these new regions? How big are they? How much of the area do they take up? Okay? I recommend, if you're having trouble getting started, because the question is talking about area, right? Well, we can think about how do you find area, right? Area equals length times width, right? Well, we're dealing with triangles now, right? So the area of a triangle is length times width divided by 2, right? Well, we don't have any side lengths, so how can we find the area? No problem. We can make side lengths. So I'm going to draw a new square, just like the red one. Same diagonal. This diagonal bisects. Okay, and I'm just going to pick a number. Right? Pick a number. I recommend picking a number that's kind of easy to work with. Maybe a number like 10. 10's pretty easy to work with. Now, on this side, right, it's a square, so all the sides are equal to 10, but on this side, we've broken up this side length into two parts that are equal. So that means that this part is 5, and this part is 5. And now we can start to find areas. We can start to use area of a triangle to find the area of some of these triangles, right? One triangle that pops out, that's pretty easy to find the area of, is the triangle created by the original diagonal, right? We'll call that the red triangle. Oh, too far. There we go. Red triangle, right? So that's going to be 10 times 10 divided by 2. So that's going to be 100 divided by 2. So this region, this red region here, combined, right? This triangle and this triangle, both of those triangles together have an area of 50. Now, just to be clear, this is not meant to be a percentage, but it does turn out that that's 50% of the whole square, so that might be helpful. Okay. We can also find the area of this triangle pretty easily, and I'll outline that in black. All right, this triangle right here, we can find the area of. That's going to have an area of 5 times 10 divided by 2, or 50 divided by 2, which is 25. Okay, that's interesting, right? So these two combined regions, right? The two red regions have an area of 50, and now this region and this region have an area of 25. Okay, well that's interesting. We have some numbers to work with. Excuse me. We have some pathways forward. The trouble is that these two, the red triangle and the black triangle, both share this, let's call it green triangle, right? They both share this region here, and so we've got to figure out how big that region is. Now, to do that, we might have to use some knowledge about triangles. So for example, you might have learned in your previous math classes about what are called similar triangles. Okay, you might have learned that similar triangles are triangles that have the same angle measures and a very important detail is that their side lengths are in the same proportion. And what's that mean? That means that if you have two triangles, let's say, so this is an example. Let's say you have this triangle here, and you have this triangle here. They're both, let's say they're both right triangles. In a square, we're going to be having some right angles to work with, so that might be helpful. And let's say that these angle measures are the same, which means that these angle measures are the same. So they're similar. If they are similar, then if, let's say, this side length is 10, this side length is 10, then this side length being 5 means that this side length has to be 5, right? They're in the same proportion. This smaller triangle is just a scaled down version of the bigger triangle. Now, why might that be helpful or useful to know? It's possible that there might be some similar triangles at play. For example, this red triangle, like just this red part, right, just this red region, might be similar to this little black section in the picture. It is possible. That is something you might need to prove to yourself, right? You might need to use things like vertical angles. Right? Vertical angles might be something that comes into play to help you prove that the triangles are similar. And so I'm going to leave you there, and you can use that to try to make some progress. If there's anything about squares or triangles that you are unsure of, let me know. I want to emphasize, right, that this is all about trying things out. So this is not a complete solution, but I hope that it helps get you started. And if you have any other questions, let me know.